Hello, everybody. Welcome to this webinar, Coloring LIDAR using 3D maps and LIDAR point clouds. This is me. I'm an engineer here at Mapbox. I work on solutions for Mapbox. We have a large cloud platform and on-premise solution called Atlas. We have four basic tenants for services of maps, search, and navigation. We're supporting multiple platforms such as iOS and Android. We also make huge use of the AWS cloud. Currently, we are at 1.6 million developers globally. We have over 1.5 billion monthly active users. We're at 71. I can't see the text there, but never mind. Anyway, we're growing, and these are the companies that we work with. You'll see Snapchat and Facebook and Lyft. Anyway, what we're here to do today is basically go through some demos. So I'll open up my screen share so we can have a look through the work that we're doing. So the first example that we wanted to go through today was the Statue of Liberty LIDAR point cloud. So using Mapbox and the Uber Engineering DeckGL libraries, what we're able to do is to build up a point cloud custom layer on the Mapbox GL.js canvas. And with this, we can get some really crazy level of detail from taking LIDAR data from the NOAA elevation website, and then we take the imagery, which is GeoTIFF, and we use a tool called GDAL to XYZ, which what we're doing is basically for every single point, so just one of these, what we're doing is we take the latitude and the longitude as X and Y, and then the Z is the height in meters. And then we allocate it one for three channels, one for the red, one for the green, one for the blue. And then we mash that up into an array. So let's dig into the source code of this so you can see kind of how easy it is. The top piece of the code here is just some CSS. And then you can see the HTML, what I'm doing right here. So I basically have just a navigation in here is this div ID in the map, because in the script, what we're doing was we're saying, take that div and then basically say, take this this style, which is the satellite version 9 style, center it on the Statue of Liberty, and then when the map starts, that you want to use this level of zoom with this bearing, and then pitch it over at 60. And then the next piece is the custom layer, which is drawing the point cloud. We're using the DeckGL point cloud layer. And then what we're doing is we're saying, go and grab all of this data, which is a JSON file. And then we're just saying, okay, for the position, we're saying, take the start of the array for X, the next in the array for Y, and the third one we're going to be doing for the Z, which is the height. And then the color, we have red and then green and then blue. and we state the size in units as meters, and then we say the point size is 0.5. Now, the reason that we're using the point size of 0.5 is that is the resolution of the LIDAR points that we get. So this is what the array looks like. If I take this URL, you'll see that I'm holding it in Dropbox. But it's really good just to browse through this quickly so that you can see exactly the makeup of the array. So here you can see the X, which is the longitude, and then the Y, which is the latitude, and then the height in meters, which is this one. And then the red is 98, and the green is 114, and the blue is 102. So this array is quite lengthy, but you can see the speed that it's being drawn into the browser. When I load it back up again, so you can see that it's already pulled the array from Dropbox and has calculated all the positions. And the other important thing to note here is that the DeckGL library is synchronizing its camera and positions with the Mapbox GL layer. So the next demonstration takes the Statue of Liberty example and basically tries to parse out a lot more information. This is obviously Donald Trump's Mar-a-Lago's residence. And as you can see, it's a lot bigger of an array, but we're using exactly the same technique to build this out. And you can see the tennis courts. It's really kind of incredible level of detail. And you can rotate through all of the data as well, zooming in and zooming out. And then what I did to go a bit further was to use some Japanese data from the Japanese government. This data isn't stored in text files like the previous examples, but it's actually stored in GML. So I had to do a little bit of work to convert and translate the raster data back to an array, and I used FME software to be able to do this. But you can see again the kind of coverage of their elevation data is quite extreme. This is obviously Mount Fiji. And you can really see the detail of this one. And then lastly, the Scottish government released LIDAR data for a huge swath of the country in Scotland. They actually have the island of Arran completely done, which is definitely going to be a future project of mine to do. However, when I was growing up in Scotland, these bridges across the Firth of Forth were kind of special to me. I actually lived when I was born in South Queensferry, and my mother has memories of me screaming in the pram, in the stroller, all the way across this road bridge. If I tip it round like this, rotate it round. So she was able to walk me across from the south all the way up to the north in the road bridge. And the other thing that's really stand out about this is the rail bridge is a very interesting design. It's kind of Victorian design. It was built in 1891, I believe, and it has this really interesting octagon kind of pattern for the hexagon patterns for the bridge spans. And if I go to North Queensferry, you can really see the details here of the houses. And the other really kind of cool thing is you can see exactly what the elevation is doing. I have a desaturated Mapbox satellite layer underneath here. And I have a mask of the water, which is why the water is looking black. But you can really see when I tilt it over how this Z values really pop because of the hill here. So it's just a beautiful way of like extending Mapbox with the deck custom layer. And again, just to show that we're doing the same sort of thing throughout and being kind of consistent. The code doesn't change here at all. Again, I'm bringing in a custom style, which is the desaturated satellite layer, and I have it centered right in the middle of the bridges with the right kind of zoom level and the bearing and the pitch. And again, I'm using the same technique to load in the array. The one thing that's definitely worth noting here, though, is that the Scottish LIDAR, the Z values for the height are based in feet. So I do a simple calculation in here to say, convert the feet to meters. And then for the purposes of data visualization, I'm going to exaggerate that height by 5 times. So with that, my demonstrations are kind of complete. What I will say is the technique does use a lot of data, and the process to be able to do this, while it's fairly simple to do, getting hold of the data and actually parsing the data into the array can be done in multiple ways. There are some things to consider, like does the time span of the image match up with the LIDAR data? So for example, if you've got LIDAR data that goes back to 2014, the image that you drape on top of it might be of the same vintage. It might be later, it might be earlier, and therefore some things to note, like for this bridges example, when you see if I zoom in, these car positions are from the image rather than from the actual LIDAR data. So it's just something to note that when you're performing this kind of analysis, that synchronizing the elevation data with the actual image is definitely a consideration.
Great, thanks, Alan. Let's get to some of your questions. If you have any for Alan, go ahead and submit them now through the Q&A window. We do have some questions that have already come in. Adam wants to know, these are 2 questions, I'm just grouping them together, is where do I find LIDAR data and the corresponding imagery data?
So initially what I did was the NOAA website, elevation website, which you can find the details on the blog post, which I believe is shown on the right-hand side of your screen. There's some links out there. It's really extensive for the United States, especially in the coastal areas. And it's really easy to download and start working with. They have a great download manager and a cart. The Scottish LIDAR data that I used is again open source, and it doesn't require much in the way of manipulation. It's on scot.gov, and if you Google Scotland LIDAR data, you'll be able to grab it. The imagery data, again for NOAA, is linked off the blog post. It's usually in GeoTIFF format. The other way to do that is you can load in Mapbox tiles into QGIS and then take a rendered image of the GeoTIFF to get the RGB colors as well. The main tool, though, is GDAL to XYZ. That gives you the values for the raster information to convert it to the XYZ for the elevation. And then for the imagery, you need to run it as a batch so that it says, go and grab me band 1 as red, grab me band 2 as green, and then lastly, band 3 is blue.
Great.
Yeah.
You just answered Rajal's question in regards to how to get that RGB info. Okay, Tina wants to know, this is great, but what can I really use it for?
So one of the kind of business use cases that I identified fairly early was real estate. I think if you were a website that was, traditionally using imagery and flat 2D maps to show either commercial or residential building information, this would be a really neat way and kind of novel way to show potential clients just a visualization of what it is that they were interested in.
Does this work for Mapbox visualization for Power BI?
Well, you could do it as a background custom map layer, I believe, with Tableau. I definitely need to check if it can be done with Power BI. But if there was a compelling business use case, then we would definitely investigate that for future capability. Yeah.
Okay, great. So Preston will follow up with you on that. How many points can you load into a view?
So this is like a performance versus crashing the web browser, frankly, question. So I have noticed that anything above 1 million points using this technique tends to slow the performance. And then you're into, how do I load the array in via the browser? There are ways around this that I'm investigating. So basically, it only loads the data using a bounding box or the viewport that the map is showing to only draw that data. So instead of using like a cloud storage like Dropbox, potentially you could be connecting it to a backend database and then point it only at, selecting the data that you only need to see at any given time. That's a way to mitigate the performance thing. In short answer to the question, theoretically with unlimited 64-bit browser, there really isn't a limit as to when it will fail. It just will take a long time to render.
Nicholas wants to know how you created that mask for the ocean.
The mask for the ocean was done using the water layer from the streets style. In Mapbox Studio, the way I did it was I took the Mapbox satellite layer, I desaturized it, and then I put the water layer from streets over the top of the satellite layer.
Can you go over again the processing steps and if there are any good starting resources for going from raw LIDAR data to GL digestible JSON?
Yeah, so the way I handle it the first time was basically reduce the elevation raster data to to a text or CSV using GDAL to XYZ. You can find that in the processing toolbox if you're using QGIS. You can also take .las and .las with the las tools processing module in QGIS as well. The upshot is you basically need the X, Y, and the Z in one file. And then the RGB comes from the image information, and it's basically you end up with 3 CSVs. You have one that's red, one that's blue, one that's green. And then you do, my method is to use a nearest neighbor plugin called NNJoin. So I basically end up with a concatenation of X, Y, Z, and R, G, and B. That way, I end up with a master CSV, and then I format that CSV so that I put the brackets around it and whatnot that I need for the point cloud layer.
And would you use that tool to combine the RGB panoramic data with LIDAR point clouds, or is there any other tool that you suggest?
To develop the array, I've used multiple tools. I've used in the past Tableau Prep. I've used Alteryx. You can do it in one go in QGIS with a calculation. To basically, you could intersect as well, potentially, the elevation with the R and the G and the B multiple times. There's a lot of methods to get around this. And, I'm pretty sure that I'm no GIS expert, and there's a ton of processes available to be able to do this kind of work.
Is there a way to tile and dynamically load massive LIDAR clouds? A single JSON file would be too big.
So right now with Mapbox GLJS, we don't do the points, but we can extrude polygons. So that it's kind of a decision to be made whether to tile polygons and accept the trade-off, because those tiles can be really, really massive. Or do you use a capability like Pottery, for example, Pottery.io, which they do streaming point clouds visualization. It's really up to the use case. I think that's the answer. And unfortunately, as much as I hate to say this, it depends.
Okay, so Eric missed the first 9 minutes, wants to know if there's some basic instructions on how to build this with Mapbox.
Mm-hmm.
But you mentioned earlier in the blog that is on the right-hand side in the resources box. Go ahead and click on that link, and it'll have basic instructions. And if you need additional information, we will also reach out to you, Eric. David wants to know, what is the process to convert the cloud data to a solid model?
Oh, that's a really interesting question. So from going from point cloud to like an OBJ file or an STL, if you're going to an STL, you could certainly use triangulation or a TIN method. You could also use a Delaunay triangulation method, which both of those are available using QGIS, which is open source, which is great. That would be my recommendation. It's not something, however, that I've actually done myself.
What resolution can you get for real estate?
So the resolution is a really interesting question. Open source LIDAR tends to be around 0.5 centimeters. I have seen 0.25 centimeters in some cases. The imagery will depend on the resolution of the satellite imagery or the ortho imagery geotiff. So typically what I do is upscale upscale to the resolution of the LIDAR. So I take the raster and I upscale it.
Josh wants to know, is there a way that the LIDAR data interacts with a chart in Tableau?
It would be feasible and it would be possible to do. You can take the X, Y, and Z values to do this and rotate it. And I have an example of that for the Golden Gate Bridge that I can certainly share. The other piece would be the RGB values, how to convert that to a tableau in a color ramp would be quite difficult, but it's not impossible. Once the data's into Tableau, then it becomes interactive and filterable and all of those sort of things. So it's you're only loading the data in once.
We have lots of good questions here. We have about 2 minutes left for 2 more questions. If we don't get to your question, we will follow up with you via email offline. Alan will definitely answer all your questions. So let's see. Let's take this one. Do we have any tools for annotating point clouds? I'm looking to create polygons in my point cloud and convert to GeoJSON.
The short answer is not to my knowledge. However, again, it's one of those things where if we have a use case that's interesting and solves a problem, we'll certainly take a look at how we can flesh that out as a solution.
So, first of all, Alton says, great demo.
Thank you.
It makes sense how this will work for aerial LIDAR, but what about LIDAR from the ground?
That is such a brilliant question. So the question points to the same principle. If you're looking at like a side-on shot from a car, so a car's obviously not oblique, it's side-on. You could certainly use the exact same principle. If you have 2 cameras in synchronization, that you have the X, Y, and the Z, then you have the RGB camera at the same angle and it's synchronized. Potentially, you're going to get exactly the same information. The limitation, of course, for what I do is that I'm top down. So when you saw that example of the houses, you don't get the inside or the skeleton. You only get the top.
Great, thanks, Alan. If we didn't get to your question during today's webinar, we will follow up with you afterwards. But thank you for joining us. And we do have 2 webinars next week. There is a link on the resources tab. It'll take you directly to our webinars page. Join us next time. Thank you.
Excellent. Thank you so much.